Okay, and welcome to an introduction for slicing and 3D printing in Dfan. This video serves as the video for Lesson 8 in Aero 206, but it's also the overall video for introducing you to slicing and 3D printing. If you've come and asked me how you can get started using the Prusa printers in Dfan, it's likely that I referred you to this video, so please pay attention. I'm going to go through a lot of important details. Okay, and here's an overview of the 3D printing process in general. We're going to start with a CAD file. So in Aero 206, we created our octoprism in Fusion 360, but you can also get a CAD file from Thingiverse or GrabCAD off the internet. Whatever source you use for your CAD in terms of creating it or downloading it, usually it comes in an STL or a 3MF file. We're going to bring that STL or 3MF file into PrusaSlicer, and we're going to go through the process of slicing it, which is where we create all of the instructions for the printer to execute to actually create the print. And that results in a file called a gcode file. We take that gcode file and load it up on the printer, insert our filament, and tell the printer to start printing. So we're going to be spending a lot of time in this video talking about the slicing process. We talked about CAD last time, and next time we'll go through how to actually use the printer. Just a quick overview of the two major types of 3D printing we have in Dfan. The first is stereolithography, where a UV laser shines on liquid plastic and hardens it layer by layer. We're not talking about that type of printing. That type of printing is not available to cadets. The type of printing we're talking about is FFF printing, which stands for Fused Filament Fabrication, also known as FDM, but that's a trademark term. So FFF is the open source term. And this is where we take a filament of plastic, we feed it into the printer. Here we have our Prusa printer that we use in Dfan. This whole assembly here is called the extruder, and the filament comes in the top of the extruder. There's gears here that push it down into a hot end down here at the bottom, and that filament gets oozed out of the nozzle, which is at the tip of the hot end, and that nozzle has a hole in it that's 0.4 millimeters wide. And then this print head moves around while the platter moves around to draw out the two-dimensional shape of each slice of the print. And then the next slice prints on top of the previous slice, etc., until you have a three-dimensional object. So this is the type of printing that our Prusa printers use, as well as our Lulzbot and our MakerBot printers. However, it's only these Prusa printers that are available to cadets in Dfan. Okay, so as I've alluded to, slicing converts that CAD model into a set of instructions for the printer, and here's what those instructions could look like. It's literally just a set of commands that the printer interprets, but there's a lot more than that in the G-code file. It contains the initialization for the printer, the toolpath for each layer, as in the shape of each two-dimensional layer, and that completely defines outer geometry as well as the interior of the geometry. So the G-code file contains everything the printer needs, and so it's very important that we go through the slicing process properly to get a good G-code file to send to the printer. So the software that we're going to be using for slicing is called PrusaSlicer. This is free software from Prusa itself, and you can go to this link, download the standalone version. You don't need to install the drivers, so just install the standalone software, and then you'll configure it. And it's very important that you select this printer when you configure it, because it's the only type of Prusa printer we have in Dfan, and I'll show you how to do that later on in the video when we get to that, and I'll also talk about these print settings later on. Okay, once we have PrusaSlicer installed, we're going to import our geometry into PrusaSlicer. As I mentioned before, there's two main types of geometry that we will pull into the slicing program. One is a 3MF file, the other is an STL file. STL is a legacy format. It's outdated, it's not as robust and useful as 3MF, but it is still very common, especially if you download parts from Thingiverse or other sites. But if you export a model from Fusion 360, you need to make sure you're exporting a 3MF file. And the other thing about a 3MF file is Prusa can actually save all of the slicing settings in a 3MF file. So you can have a 3MF file where it's just your geometry that you exported from Fusion 360, and you can also have a 3MF file where it is the geometry in the right orientation with the right slicing settings to generate a G-code file to send to the Prusa printer. From a big picture perspective, our goals for this step is to make sure that our geometry is the correct size, that there wasn't a units conversion issue from inches to millimeters or anything, that we orient the geometry in the best way possible to reduce overhangs and support, and that we orient in the best way possible to help it to stick to the bed during the printing process. Okay, so the first and primary variable that we need to decide on for our print job is the height of each one of those two-dimensional slices or layers that the printer is going to print out. We have to realize that the height of those layers is really only going to affect the resolution of the print in the vertical direction. The resolution of the print in the XY direction is governed by how small of steps the motors can make to move the print head in the XY direction, for example. Okay, so big picture here, our goal is to reduce the print time of the print, but still produce enough detail to make us happy for the part for whatever we're using the part for. So here we have the same part printed out with a 0.2 millimeter layer height and a 0.1 millimeter layer height. And you can see the print time more than doubled for the 0.1 millimeter layer height, but step back and look at both of these parts. Both of them look pretty darn good. And the only area where you can even see that layer height come into play is at the top of the ball, which is really where you start to have a lot of change in the vertical direction for each increment of layer up. And you can start to see that layering happening at the top of the ball. I'm going to argue that most of the time that effect that you're seeing there is very insignificant, and it really doesn't matter to the functionality of the part, and it's not worth it to double or cut your layer height in half to get rid of some of those contours along the top of those areas where there's large changes in the vertical direction. So we're going to start with a layer height of 0.2 millimeters for our parts. Once you have a part that prints very well, we could try to reduce it to 0.15. Very rarely will I ever go to a 0.1 millimeter layer height. There's just very few times where it's actually worth it. Okay, so as I talked about earlier, the FFF printer extrudes out a two-dimensional layer of plastic, one after the other, and the successive layers cannot print on thin air. They need the previous layer to support them while they're being printed. And we can kind of see that happening here on the left with this 30-degree upside-down wedge. As the printer gets up to these layers up here, the print head is printing slightly outside of the previous layer. However, part of the next layer is still being supported by the previous layer. And that's even true if we have an overhang at like 45 degrees. The print head is going to be extending the next layer out a little bit further than the previous layer, but it's still supported a little bit by the previous layer. When we start getting to overhangs of 60 degrees or 70 degrees and higher, you really can run into issues where the next layer up is not being supported well enough by the previous layer. And that's where we need to add supports. This is where the discussion of supports comes in. So this is a support tower here that's helping to support it. The only bad part about this picture is this is a 60-degree angle everywhere here, and so everywhere would need support, not just this one place on this overhang. For a 90-degree overhang without supports, the printer is just extruding out a bead of plastic on thin air, and that bead of plastic is going to fall down, and then the printer is going to go back to extrude the next layer out, and that layer is going to fall down. And eventually there's enough in this rat's nest that it starts to support the layers on top, and eventually you'll start to have these layers that are the correct geometry. But all of the unsupported initial layers underneath this 90-degree overhang are just absolute trash, and the original geometry did not print at all. So this is an area where we would definitely need supports with the 90-degree overhang. The goal with creating supports is to ensure that the part prints successfully, but also minimizing wasted filament. Because if we printed this part and we needed to put supports under this whole overhang, we would be doubling or more the amount of filament required to make this print successful. So we want to think about what is the best orientation to put the part in to minimize the supports, and I'll show you what that looks like later. Okay, and there's also an interplay between unsupported overhangs and layer height that's happening here. Here we have two cases where we have the same overhang, but a different layer height. And for the larger layer height, basically we're going to have to take a bigger step out over the previous layer to achieve that overhang angle. And that's going to result in potentially poor quality in that overhang because we have so much of the layer sticking out above the layer below. Okay, but if we have a smaller layer height, basically we're discretizing this change, this slope, into smaller steps, and each of those steps extrudes out a smaller amount over the previous layer, which means that we'll be more successful printing an overhang with a smaller layer height. So that is a potential remedy if you're having trouble printing an unsupported overhang. First of all, you could add supports, but secondly, you could lower your layer height slightly to see if that helps you print those unsupported overhangs a little better. Okay, we also need to change the settings for the interior of the part. We do not need to make a part that's 100% plastic on the inside. It's a complete waste of filament. Okay, the amount of filament that we put on the inside of the part depends on what we're using the part for. If it's just going to be something that's sitting on your shelf and it's really just a display part, 10% is fine, or even 5% is fine sometimes. If it's going to be a load-bearing part that's supporting some weight, maybe as a part of an experiment or something like that, 20% is normally fine. 30% if you want it to be extra strong. And there's very rarely ever a use case where you actually need a part to be printed at 50%. So the areas that we're going to range for our stuff in Aero 206 is anywhere from 5 to 15%, depending on what your part might look like. And the reason that we want to tune the infill is because, again, we don't want to waste filament printing out parts at 50%, and we don't want to waste time. When we're printing out all of this dense infill, it takes a lot more time for the part to print. After we have those major things set up and the layer height, which I'll talk about in a little bit, we can slice the part, and I'll show you what this looks like in PrusaSlicer when we get there. But basically, once we slice the part, we're going to inspect it very carefully to make sure that we can't predict any failures. And then once we have the part sliced, we're going to export the G-code and be able to send it to the printer. The Prusa printers use SD cards. So there's an SD card on the side of the printer. You're going to have to take that out, put it in an SD card reader, put it into a USB port on your laptop, and export the G-code to the SD card. The second thing we're going to want to do before we close PrusaSlicer is save our slicing setup as a ready-to-slice 3MF file. And that way, if we need to make a tweak to the slice, we can open that file and pick up right where we left off in terms of slicing it. And there's a lot more detailed settings in PrusaSlicer. Basically, we're going to be spending most of our time with these settings and print settings and not changing filament settings or printer settings. Okay, so here we are in PrusaSlicer. I've got the platter open in front of me, and this is what the print bed of the Prusa i3 MK3S Plus printer looks like. And so we want to arrange our part on this platter and slice it on the platter itself. Before we get to that, I'm going to go up here to Configuration Wizard, and I'm going to show you how you should have PrusaSlicer set up. So we're going to go to Prusa FFF printers here. When you first install PrusaSlicer, this Prusa Mini will be selected with a 0.4mm nozzle. You need to uncheck that. We don't have any of these printers in Dfan, and if you sliced for this and tried to send it to one of our printers, it would be really bad. The kind of printer that we have in Dfan is this one right here, the original Prusa i3 MK3S and MK3S Plus with a 0.4mm nozzle. Do not check any of these other nozzles. You will not need them. Do not check any of these other printers in your setup. The only printer you need in your setup is this one with a 0.4mm nozzle. The other thing that we can set up in the configuration wizard is the filaments. Okay, and we need to make sure that we have some of the correct filaments loaded, and the filaments that we're going to use for all of your printing in Aero 206 and most of the printing you're doing as a cadet will be a PLA filament. So really the only one you need to check is Prusament PLA. That's our Dfan supplied PLA for doing any types of class prints. If you do want to do personal prints and you go out to Amazon and want to buy some 1.75mm PLA, what we generally recommend is Hatchbox PLA. So you can check Hatchbox PLA here, and that will print very well with those settings. You don't need to select any of these other types of PLAs. It could just end up causing confusion or mistakes. Finally, in view mode here, you'll want to put yours on advanced mode to be able to get to some of the settings that I'm going to talk about. There's very rarely a case where you'll need to use expert mode. So click finish, and now PrusaSlicer is set up with the correct settings, and it should look like this with this type of print bed. So now we need to get our part onto the platter. Okay, so I'm going to drag and drop my part onto the platter, and in this case it's an STL file. This is an STL file of a wire holder that my son made using Tinkercad, and it's just going to make a good demonstration for some of the things we need to think through when we're slicing this. Sometimes when you drag a file in like that, it'll give you a pop-up warning saying, we think the dimensions are in inches, do you want to convert them to millimeters? In which case you should probably try to answer yes. If it doesn't work, just go back and drag it and drop it and answer no. Okay, so the first things we have to decide when we're printing this part are the layer height and the supports. So we have the layer height up here, and as I mentioned earlier, I strongly recommend that you start off with a 0.2mm layer height and just see how your part prints for the first time, see if you like the quality, and if you have a really hard time with the quality in some areas, then you could do a second print job at 0.15. In most cases, 0.2mm layer height is going to be absolutely fine for our prints. Sometimes I go to 0.15 millimeter layer heights. Rarely have I ever saw a need to actually do 0.1 millimeter layer heights where I actually had that much vertical resolution that I wanted to resolve. And please never ever choose 0.05 or 0.07 with our printers. You're going to take up a ton of time on the printers and you're not going to see a ton of benefit in your parts. And sometimes problems can arise with those layer heights in terms of the parts peeling off the bed and things like that. Okay, I've got my filament selected to PrusaSlicer PLA because that's the Dfan filament that we're going to use, and I've got my printer selected, and the next thing that I need to select is the supports for the model here. Okay, I'm going to leave the supports on none just so we can get an idea of what's going to happen if I print this without supports, and obviously I'm going to have some big overhangs here that are going to be a real problem. So I'm going to hit the Slice Now button, or you could hit the Sliced Preview. Either one will accomplish the slicing of the part, and basically it converted this part into a bunch of two-dimensional slices that the printer will print out. And I can drag this layer bar down here to see what each layer of instructions looks like when it sends it to the printer. So first of all, I'll notice the only thing touching the bed of the printer is this very edge of that kind of ring that was on the outside of the spool. So that's the only thing touching the bed of the printer. As I go up in layer height, it starts to come out pretty fast, but if I look at it from the side, I can see the overhang that I have there is unsupported, but it looks like that'll be fine. As I continue to go up in the layers, all of a sudden I see the rest of the spool jump out to the sides. And this overhang right here is a 90-degree overhang, and this will fail. This needs supports under it, or else this plastic is just going to droop down, and the print's essentially going to fail, and it's going to look horrible. Okay. But continuing on in the layer heights, as I come up, I start to get into the center of the spool, and then again I'll reach the top of the spool, and again I have another 90-degree overhang here, and the printer's coloring it that color because it's detecting an overhang. And again, the slicing software is saying the printer can't just print over thin air, so all of this plastic it oozes out here is just going to fall down, and it's not going to be a successful print. Okay. But that's the slicing for this orientation. Again, we need to bring our geometry in and orient it and manipulate it into the best position to reduce the amount of supports required. We can see here that this print job will take about 5 meters of filament and will take 2 hours and 6 minutes, so we'll just keep that in mind. I'm going to go back to the platter view, and we need to find a better way to print this part, and the next step would just be to turn on supports. So here we have our supports menu. We have 3 options: support on the build plate only, for support and forces only, which is where we tell it to support, and everywhere. I'm going to turn on build plate only so we can see what that does, and just answer yes to this question here. And now I'm going to hit slice again, and I can see that underneath of this bottom overhang, it's building a support structure all along here to hold up this bottom half of the spool, okay? Which is great. If I go through the slices now, I can see this support structure on the bottom, and I can see that when this first layer shoots out with that 90-degree overhang, it's going to be printing on that support structure, and so I'm going to have a nice successful print here. However, because I selected supports on the build plate only, it's not building any supports off of the part itself, and that's the only way it can support this top half of the spool is by building support off of the bottom half of the spool. So what I need to do is I need to say supports everywhere, and then I need to say slice now. And now it's filled up the inside of the spool with supports in order to support that top half of the spool. So if I drag my slicer down, now I can see all these supports that have been put inside the spool. And so when it gets to the top half of the spool is going to have plenty of support to print out on. And this print is going to be successful, not going to be any issues with it, other than it's going to be a pain in the butt to use pliers and rip out all of these supports afterwards, and it's wasting a lot of filament. Now we're using 8 meters of filament, and it's taking closer to 3 hours. So we added on 50 minutes of print time just to support this everywhere. So there's got to be a better way to print this part that requires less support but still prints it successfully. So let's try to figure that out. I'm going to come back here into the editor view, and I'm going to start to manipulate the object around. First of all, I got a lot of controls over here. I can move the object around on the bed, or I can just drag it around with my mouse wherever I want it to go. I can scale the object using these scale bars, but I would recommend scaling it with these scale factors down here that just apply them uniformly in each dimension. So there's a 200% wire spool. I can also rotate the part. Okay, so I can grab these rotation bars and rotate the part however I want to try to rotate it. And this is probably the most powerful button here, is place on face. We can just immediately reorient the part by placing it on any of the detected faces on the part. Okay, so I'm going to click on place on face, and PrusaSlicer is detecting all of these faces around the perimeter and basically saying I could try to print it on any one of these faces. So I'm just going to click on one of these, and it puts the part up on that face with that face directly touching the bed. And this is the new orientation that I can try to print the part in. So I'm going to leave supports on everywhere, and we're just going to see how this thing will look when it's printed and how long it's going to take. So I'm going to hit slice now. And, you know, first glance, that looks like a lot less support. And yeah, it's only using 6 meters of filament. So we're saving a lot of filament, but it is taking a little bit longer to print because it does have to go higher now than it did before. It has to print the object a lot higher now than it did before. But it's worth it for an extra 6 minutes of print time to save almost 2 meters of filament. That's a win in my book. But we have some concerns with this part still. Obviously, one of the concerns is if we go down to the bottom layer here, we only have a tiny part of the wheel that's actually touching the bed to start, and it's this part right here. Okay, so while the printer is printing, the head is touching it and it's imparting some force to the top of the part, and if there's a big enough force on the top that causes a moment that causes these contact areas to break loose of the bed, then the part could actually come off the bed and start sliding around while it's printing, and that's going to result in a completely failed print. Now luckily, as we go up in layer height here, the bottom of this part is pretty securely supported by these supports around it, so I don't think this part is going to go anywhere while it's printing, so that's the good news. However, if we didn't have all of these supports around the bottom of the wheel, adhesion to the bed could be a real issue for this print. And to show that, I'm going to turn off supports and just show you better how much of the wheel is actually touching the bed. And from this view, if I go down to the first layer of the print, you can see there's only a tiny spot on each side of the wheel that's actually touching the bed. And it's just these two tiny spots that the whole part is relying on to stay fixed on the bed in one place while the print head is moving back and forth on the top of the part printing it. And so it's very likely that this part will come off the bed during the print. It'll end up sliding around underneath the print head. We could end up with a ball of goo of melted plastic under the print head, or a rat's nest of just filament squirting everywhere. And so we want to watch out for this whenever we part parts that only have a small amount of contact area with the bed, or that are very tall parts and relative to their height only have a small amount of contact area to the bed. And besides adding support around the bottom, which works for this part, but it wouldn't work for some other types of parts, the other tool that we have to increase the area of adhesion to the bed, the contact area, is a brim. And so if I go to print settings here and go to skirt and brim, I can turn on a 5mm brim by typing in 5 here, and I can turn off the skirt, the lines that go around the part, because often the skirt and the brim can overlap. And when we turn on the brim, we usually want to turn off the skirt. Now I can go back to the platter and reslice this part. And now you can see that there's some extra plastic around that first layer, and it is going to be in contact with the part, and it's going to be in contact with the bed as well. So it's going to provide some extra adhesion to the bed for that first layer, and it's going to help this part stay in place as it gets bigger and bigger during the print. So the brim is definitely an important tool that you want to keep in mind for when you have something that has a small contact area with the bed. In this case, this part would probably be well served by using a brim and supports, and that would probably help it to stick to the bed very, very well. I think we could still save some supports though, because look at the top of this inner hole here. As we get around the top of this, we don't need to start supporting it right here. You know, we don't need to start supporting it until closer to the peak. So we're going to try to tune this a little bit. I'm going to go back to the platter view, and I'm going to go to print settings, and I'm going to go to support material and overhang threshold. And you can read the description here, but basically the overhang threshold defines that overhang angle where PrusaSlicer will start supporting it. And so if we lower this down to 20 degrees, basically it will reduce the amount of overhang that gets supported unless it's within 20 degrees of horizontal. So I'm going to go back to the platter and slice now again, and we can see that it resulted in a lot less support material inside, And from experience, I know that the inside of this circle will still print just fine. And the good news is we reduced our filament again, so we're saving about 1/3 of a meter of filament. The bad news is down here at the bottom, this is really not supported well enough at the bottom, and this part is probably going to come off the print bed and start sliding around while it's printing, which is going to be absolutely no good. So we need to enforce some supports along the bottom to make sure it sticks to the bed, but leave these minimal supports on the inside. So I'm going to go back to the platter view. I've got the object selected here, and I'm going to go to this paint tool here, which is paint on supports. And basically this lets me use this little paintbrush tool here to tell PrusaSlicer I want some extra supports here, here. I'll tell it to do it over here, and I'll tell it to do it over here. So that way we get a little extra support along the bottom, and hopefully we'll keep this part from sliding around on the bed. And sure enough, after I did that, I've got some extra supports along the bottom on both sides, and so I think this part is pretty much ready to print now. And we're coming in at just under 4 hours and just under 6 meters of filament, so it's not terrible. Okay, I'm just going to show you a couple other tools though before we get too far into it. This next one is the split tool. And this one is really handy because I can split any object right here in PrusaSlicer for better printing. So in this case, I'm going to perform this cut and split this part into 2 halves, and then I could print these 2 halves like this and then glue them back together with epoxy or something after they're done. And in this case, I think this thing could print without any supports at all. Maybe a little bit of support underneath the top of this arch. But even if I didn't put supports there, it would still come out fine. It would just be a little bit rough on the top. So I'm going to say supports for support enforcers only. I'm going to go back to the painting tool, and I'm just going to ask for a little bit of support right there. And I'll click on the other part here and go to the painting tool, and I'm just going to ask for a little bit of support across the top there. Okay, and so now I told it, only give me supports where I'm exactly asking for them, and then I use the paint on tool to say this is exactly where I want supports. Okay, so kind of achieves the same thing as just setting that overhang threshold in the print settings. But regardless, this got the print time down to 3 hours and 40 minutes, and it saved a little bit of filament. But I'm going to tell you what, in this case, it's not going to be worth it because gluing this thing together is going to be more of a pain than just printing it off with a little extra support. But I just wanted to show you that split tool and what that split tool can do for you. Okay, we have some other controls up here at the top, just in regards to the part adding or deleting parts, or increasing the number of parts and then automatically arranging them. Okay, we can do that kind of thing here. And we also have a button here for variable layer height, and this is where we can actually add some detail by lowering the layer height in the areas where we need it, like right on the top of this arch or on the top of the wheel. We could lower the layer height by putting our mouse where we want that green band to add detail, and left clicking to lower the layer height, which would add some detail in that area. So that's a really good way just to lower the layer height a little bit exactly where you need it, so that way we don't waste our whole time printing the whole part at a small layer height. We just add the detail right where we need it. Okay, so that's an overview of just some of the major slicing things that we want to think about. I'm going to clear off my platter now and start off with a new project. Okay, so now I'm going to slice my octoprism and talk about just the last few considerations. So I'm going to drag and drop my octoprism. This is a 3MF file now this time. Okay, and it's giving me an error saying that there's part of the object that's outside of the printing area. And when I look over here, I see this dark blue color showing the part of the octoprism that's outside the print area, and the light blue is inside the print area. This is a really important point, okay? When you guys make your airplanes in Project 4 in Aero 206 and you import them in PrusaSlicer, sometimes they might show up way off in the distance over here, and that's because your model in Fusion 360 is not at the origin of the coordinate system in Fusion 360. And the origin of the coordinate system in PrusaSlicer is right here at this corner. So when you import your airplane and it's way off in the distance here, it's because that's how far away your airplane is from the origin in Fusion 360. So go back to Fusion 360, move your airplane so the nose is on the origin, and then export the 3MF file and come back to PrusaSlicer to import it. Okay. In my case, I made my octoprism centered on the origin, and sure enough, it's centered on the origin right here. So I'm just going to drag it over so it all turns green and it's all inside of the print area. All right, so again, we need to decide on the layer height and First of all, so I'm going to go with a 0.2 millimeter layer height because that is absolutely fine for this project. And we also need to decide on the infill, and it's defaulting to 15% infill, and honestly your octoprism will be perfectly fine at 5% infill. If you're very concerned about it, you can do 10% infill. There's absolutely no need to do anything more than that. So I can hit the slice button right now and just see what I get. And here's the slice preview of my octoprism, and I can go through the layers. And first of all, starting at the first layer, I can see I've got a large contact area with the bed of the printer. That's going to adhere very well to the bed of the printer as long as my first layer is calibrated, which we'll talk about in the next video. And so with this slicing here, I'm pretty confident that the part's going to stick to the bed. I'm not going to run into any issues with it coming loose. As I go up here, I see that 5% gyroid infill filling in there, which is just, it's plenty of infill. And then I see the embossed and debossed letters and shapes on the sides. And then as I come up to the top, now as I talked about in the CAD video, there's absolutely no need to support a 2 millimeter overhang like this or like the edge of the F16 here, okay? This small of an overhang, the printer will extrude some plastic there, but it won't start drooping down very much because it's such a small overhang, and then the next layer will come out fine. So at the most, there might be one layer here that looks a little bit strange, but you're not even going to be able to notice it unless you're looking for it. And of course, now that I've said it, you will look for it, but it's otherwise fine. The one overhang that we do need to watch out for is this peg that's sticking out right here. That's sticking out way too much to be an unsupported overhang. So we need to add supports to that. So I'm going to go back to the editor view here, and we need to figure out how to add supports. Now, if I say support on build plate only, it's going to support everything, okay? It's going to support all these other little overhangs that I don't want to support. It's going to support the back of the F16 and all that stuff, and I don't want any of that supported. The only thing I want supported is this peg that's sticking out. Okay, so I've got two options here. One of the options is I can block the supports on the areas where I don't want them, or the other option is I can turn off supports and only enforce supports in the areas where I do want them. Just for the sake of demonstrations, I'm going to add a support blocker to the F16 here. So I'm going to right-click on editing this part here, and I'm going to say Add Support Blocker, add a cylinder, and now I've got this other part here that's a cylinder on the print bed, and really it's just a modifier. I'm going to scale this up so it covers this side, and it doesn't matter that it's sticking down below the bed or anything like that. What this is going to do, it's going to block supports everywhere inside of that cylinder. So now, if I slice now, I don't have any more supports on this X16 because I just used that cylinder as a support blocker. So now this is looking pretty good. I've still got some supports here on my name on the other side, so I could come back up here to my part, and I could say add a support blocker again, add another cylinder, put it over there on my name, and then slice now, and now those supports are gone. So adding support blockers is a really key way of telling PrusaSlicer where not to put supports. But again, I could reverse my strategy here and just tell it to support this one peg. So I'll just delete these two cylinders that are sticking out here, and I will say for support enforcers only. I'll go back to my editor view, I'll click on my part, I'll click on paint on supports, and I'm just going to paint on a little bit of supports at the tip. I don't even need to paint supports all the way to the root of this overhang, because there's something called bridging in 3D printing where it can actually bridge a piece of plastic from one supported part to another. So if I just support the tip of this, it should be fine. I'll hit slice now. There's my support tower going out to the top, to the tip of that peg. It'll bridge across the middle of this peg. That will come out absolutely fine. And so I've really minimized my supports here just by pinpointing the exact area where I wanted supports. And my print job here is 2 hours and 16 minutes and using a little under 8 meters of filament, which is pretty good. Okay, so it's time to export our G-code, and we want to export our G-code directly to the SD card that we will put in the Prusa printer. And I know a lot of people haven't used SD cards before, so here's the SD card here. You'll usually find it in the printer already on the left-hand side of the orange control panel. So you'll have to take the SD card out of the printer. You'll have to put it into one of these SD card readers that you'll find normally lying around the printer station, and then put that SD card reader into a USB port on your laptop. This SD card can go into the SD card reader. It looks like it can go in two different ways, upside down or right side up. But in reality, you'll only be able to fully insert it in one orientation. So if it doesn't feel like it's going in all the way in one orientation, try to flip it around and see if it will go in all the way the other way. The trick is to look for the leads on the tip of the SD card, the electronic leads, and normally those face the interior of the SD card reader. So normally you can put the SD card into the card reader like that, put the card reader into the laptop. Once you put that card reader into your laptop in PrusaSlicer, you will see a little button pop up here that says export directly to the SD card. So we could export the G-code to somewhere on your hard drive, but I highly recommend that the only place you export the G-code is to the actual SD card you'll put in the printer. There's no need to save the G-code on your computer. It's hard to view the G-code. It's hard to remember the slicing settings that you used in the G-code, so it's really hard to make use of a bunch of old G-code files that are lying around on your hard drive. The only place you need to put the G-code is on the SD card. So click on this SD card export button and then save it directly to the SD card like that. And then you can eject the SD card using this button right here and then go put that SD card into a printer. But we don't want to lose all the progress we made setting up this slice. So we want to save our progress here. We just don't want to save it as a G-code. On our laptops, we want to save it as a 3MF file that's ready to slice. So I'll go to Save Project As here, and I need to enter a name for my 3MF file, and the default name is fine, except now I want to remind myself that this 3MF file contains all the slicing settings, so I'm going to call it RTS, in other words, ready to slice. So if I save this ready to slice 3MF file, I can always reopen it with PrusaSlicer and easily export the G-code again. And that's a lot better than just saving the G-code on your hard drive, because you can lose track of what the G-code actually means. Whereas in the ready to slice 3MF file, you can just see the geometry, see all your slicing settings, slice it again, and export it to the SD card again. Okay, so with that, I'm going to export this SD card and go put it in the printer and start printing. Okay, there are just a couple other gotchas that I want to make sure you guys know about. Okay, so I'm going to drag an STL file onto the plotter here that I downloaded off of GrabCAD or Thingiverse. Honestly, I forget where. And this is the YF23 that we love to print so much in Dfan, okay? But I want you to notice this little warning triangle here next to the STL file. And that's because this STL file came with a bunch of errors in it, and PrusaSlicer tried to repair them itself, okay? And sometimes when you slice this, it still may not be repaired all the way. And in this case, after I slice it, if I zoom in here around the cockpit, I can see that I've got some major issues with the cockpit here. It's printing out an interior cockpit because this STL file that I grabbed off the internet, somebody actually modeled the cockpit. And so this is going to be really hard to print, and it's producing some errors around the edge of the cockpit here. I can click on this warning triangle next to my STL file, and it will export this file to a NetFab online repair service. It'll repair it and it'll re-download it into PrusaSlicer, and then I can hit slice now again, and I get a much better slicing now without all of those overhang errors and warnings around the cockpit, okay? And it still has the interior of the cockpit, but it doesn't have all of those mistakes around the outside of the cockpit. So I just want you to be aware when you download an STL file off the internet and you see that warning triangle next to it, it's worth it to try to repair the STL by sending it to NetFab. The other thing that I want to warn you about is trying to print and slice thin parts, okay? The nozzles that we have on our printers are 0.4 millimeters wide. So it's physically impossible for the printer to print a feature that's smaller than 0.4 millimeters wide, and the printer will just ignore any features that are smaller than that. For example, trailing edges, where the wing comes to a very thin edge at the back. Sometimes, especially when you scale your model down, those trailing edges can be less than 0.4 millimeters wide. And so the printer can't even print them. So on the left here, you see my unsliced raw geometry of an F104, which shows the wing shape that I actually made in CAD. But when I go to slice it, PrusaSlicer can't slice the back of this wing because it's so thin. So it can't even start printing until the wing gets thick enough to where it's 0.4 millimeters thick. So what happens here is PrusaSlicer puts supports underneath the wing to where the actual geometry comes, but then in reality it doesn't start printing it until it gets thick enough, and I end up with this gap between the supports and the wing. And this part will fail because the wing is unsupported, and beyond that it won't even look like a real F104 because the wing will be a different shape. And look at the tail here. The tail just became this little triangular tail here with a lot of area missing compared to the actual geometry. So this F104 is going to look a lot different than the CAD file that I made in Fusion, and it's because I ended up with parts that were really, really thin, and PrusaSlicer just can't even print them. So there's 5 possible solutions that I've come up with for this problem. The first and best solution is to make the wing thicker in Fusion 360 a little bit, and I'll show you how to do that in Fusion. The second solution is to make the part bigger in PrusaSlicer, and as the part becomes bigger, the smallest feature also becomes bigger, and there's a chance it may be able to print more of the wing. But sometimes you may not want to make your part that big in PrusaSlicer, so that may not be a good solution. Sometimes, if you draw a sketch at the trailing edge of the wing that's 0.4 millimeters thick and extrude it into the wing, then you're guaranteed to have a 0.4 millimeter minimum thickness on the trailing edge of the wing that will print. So sometimes we have to do this. Another solution is to print the aircraft nose down. If you can support the nose good enough so the aircraft won't come off the bed of the printer while it's printing, this will let the printer print the leading edge first, which means the print will get supported, but it still means the trailing edge will come out to be a different shape. It just means that it won't fail because it was unsupported. Finally, you could try to print your aircraft in more of a horizontal orientation, and this will cause more of that thin trailing edge to be rotated down into the XY plane, where the printer can actually resolve a smaller feature than 0.4 millimeters because we can go down to a 0.2 or 0.1 millimeter layer height in the XY plane. Okay, so these are I've kind of presented them in order of preference. The first and best option is just to make the wing thicker in Fusion 360. So that's what I'll show you right now. Okay, so I've got my F104 here in Fusion 360, and the key to this is going to be to make sure that these wings and tail are not combined with any other bodies. If you combine this all in one, this trick will probably fail, and you need to uncombine it. So go back in your timeline and uncombine these things, and then try to make the wing thicker. And the tool that we're going to use is the press-pull tool, and we can just click on a surface or a face of the wing, use the press-pull tool, and we can actually just pull it out and make it a little bit thicker. Now this tool is kind of like the fillet tool, where if we just grab that handle and pull it out by a bunch, the operation's probably going to fail. But if we type in small numbers here and only do small changes, we can see the wing get thicker slowly. Now we're losing part of the wing shape here, that's for sure, but I've kind of exaggerated how much thicker we need to make it in this case. In this case, I only had to make it 0.2 millimeters thicker, which was 0.4 on both sides. And this actually still looks pretty airfoil-ish and results in a successful print. So this press-pull tool and making your wing a little bit thicker is the first solution that you should try for that thin part problem.